Good day, grade 12 learners. Welcome to today's technical mathematics lesson. My name is Matsidiso Kongwani. This lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. Remember, grade 12, our WhatsApp number, please note it down, is 079 578 2908. I'm repeating the number. That is 079 578 2908. Grade 12s, you are more than welcome to send your clarity seeking questions to that particular number or any alternative solution that you would like to share with us. And today we are looking at the paper 2 revision, since we are writing our prelim paper 2 on Monday. And then we will be looking at the trigonometry out of all our paper 2. And then by the end of this lesson, you should be able to, number 1, know the basic trigonometric ratios and its reciprocal. Secondly, to calculate without using a calculator, referring to special angles. And then thirdly, to simplify trigonometry expressions or equations using a calculator. And then number 4, to simplify trigonometry expression and equations, in this case now using identities. And then number 5, to apply the reduction formula. Number 6, to determine the solution of trigonometric equations. And then to apply sine, cosine, and area rule. We are applying sine, cosine rule where we are solving 2D and 3D problems. And then now you must also be able to sketch and interpret your trigonometric function. And then now we are having a key to achieve greater than 40% grade 12 on your paper 2. It is possible, grade 12, that you can achieve a mark that is greater than 40%. And then we have a strategy here that we'd like to share with you. Remember now, topics that you find on paper 2 is your analytical geometry, your trigonometry, your Euclidean geometry, your mensuration, circles, and angular movement. Okay. Now with analytical, the weighting that will be out of your 150 mark, total mark, the analytical geometry is taking 25 plus minus 3 out of that 150. Trigonometry is taking 50 plus minus 3 on that particular. Can you see that the trigonometry is dominating in terms of marks? That is why we've decided to look at that topic, because it is carrying too much marks on that particular paper too. And then Euclidean is 40 plus minus 3, also a lot of mark, grade 12. And then our mensuration, circles, angles, and angular movement, it is carrying 35 plus minus 3. And then this adds up to 150, of which is our total for paper 2, grade 12. And then now we have targeted marks out of each topic now in order to achieve that greater than 40% mark. So out of analytically, if you can manage to get plus minus 22 grade 12, and then you are expected to do all the topics out of analytical, that is from grade 10 to grade 12. You must be able to answer everything on your question paper, grade 12. And out of these 25 marks, please collect 22 marks out of this analytical, because it is the easiest topic that you can answer on paper 2. And then out of our trigonometry, out of 50, please ensure that you can get plus minus 20. What are you focusing on? The definitions, your identity. Remember, you'll find at the back of your question paper, reduction formulae, equations, and your trigonometric functions. And then out of these 50 marks, grade 12, if you can be able to collect plus minus 20 marks, you will be able to reach greater than 40%. And then under Euclidean geometry, we are focusing on, we are targeting the 13 marks out of the 40. So if you can revise most of your grade 11 Euclidean geometry, that is the circle geometry from grade 11. You can reach this plus minus 13. And then now with mensuration, circles, angles, and angular movement, we are targeting 20 marks out of this 35. And then what you need to look at, your mid-ordinate rule. Do you remember the area of the irregular shapes, grade 12? You must master that. That is the easiest topic. You just have to analyze and then substitute on the formulas given to you at the back of your question paper. And then converting radians to degrees and then degrees to radians. There will always be a question on that one, either here or on your trigonometry. And then be able to calculate the area of a sector or the area of a segment. And then you must know your conversions, grade 12, converting degrees to radians, converting your hours to minutes and to seconds. You must be able to convert your units, meters to kilometers, millimeters to centimeters, and so forth. And then angles and the arcs. You must know your angles and arcs. And therefore, if we can manage to get this particular targeted marks, grade 12, you'll be having 75 out of the 150, which leads you to 50%. I hope this is clear, grade 12, and then can you see that it is possible for you to reach a 50% on paper 2. And then analytical geometry, on your formula sheet, you have formulas, and then they are not classified for you, but immediately after the paper 1 formula, you'll be having the analytical geometry formula starting from D there on your formula sheet or information sheet. And then that is the distance formula. And then this is the midpoint formula. That is an equation of a straight line, equation 1 and equation 2. It's up to you, grade 12, you want to use which one, but it works well with both of them. And then this is our equation for the gradient of any line, where we have your y2 minus y1 over x2 minus x1. And then now this one is for the angle of inclination, where we are using tan theta is equal to the gradient of the line in reference with. And then now we have the equation of an ellipse. And then this must always be given in the form that it is equals to 1 on the right-hand side, grade 12. Be careful now. If you look at the formulas, all of them are saying x2 minus x1, y2 minus x1. When you look at the gradient, y2 minus 1, x2 minus x1. But with the midpoint 1, it is exceptional now. We are saying x2 plus x1, y2 plus y1, grade 12. Please visit your formula sheet throughout your exam session so that you can deal with these mistakes, possible mistakes that you can encounter there. And then under trigonometry now, we are having the sine rule, of which is this one. It is A over sine A, and then this A represents a side, and that A represents an angle. And then which is equal to B over sine B, and then which is C over sine C. When can you use this one? You can use a sine rule if you are given what, grade 12? The two sides and the one angle opposite to that given side. Okay? Then you can be able to use this. Or you must be given two angles, and then with one side that is corresponding to one of the angles. Those are the only conditions where we can use the sine rule. And then with the area and the cosine rule, this is our cosine rule, this is the area rule. To use the cosine and the area rule, you must be given two sides and an included angle. That means it must be an angle between those two sides. It must be included, an angle between the two sides, okay? Or either for the cosine rule, you must be given all three sides, so that you can be able to find this angle here, which goes with the cos A there. And then now we have our identities. Now from this level now, we are having our trig identities, of which the first one is a sine squared theta plus cos squared equal to 1. You can play around with this one. You can decide to leave a sine theta there and you'll end up with 1 minus cos squared theta, transposing cos theta to this side. Or you can leave a cos squared theta and then you transpose the sine, it will be 1 minus sine squared theta. You are welcome, grade 12, to play around with that particular identity. The same applies there. Okay, these identities, as you can see, they work only with when they are squared. These are square identities. You can't use them without the squares that you see there. Okay, and then also we have 1 plus tan squared theta equal to the sec squared theta. You can also play around with this one. You can take 1 to that side and then leave the tan squared theta here. And then you'll be having the sec squared theta minus 1. So grade 12, that is how you can play around with this. Or you can take sec to that side, it will be 1 minus sec squared theta, which will be minus tan squared theta. It doesn't matter, grade 12, how you play around with this. You are more than welcome to do that. You can leave the cot squared theta there and have your cosec squared theta minus 1. The same applies. You can take your cot squared theta to join your cosec there and be left with the 1 on the left-hand side. It is still right. Remember now, on this identity, do not forget an identity that a tan on theta is equal to a sine theta over the cos theta. Remember, this is the only identity that do not work with the squares. But this one is a must. They must be squares on them before you can apply that identity. And remember now, a radian is equal to 180 degrees. 1 radian is equal to 180 degrees. And then with circles, angles, and angular movement, we are having these formulas. Grade 12, you'll also find them on your formula sheet. I've already talked to radians because you also have radians on circles, angles, and angular movement. And then we have the angular velocity formula, circumference velocity formula, 2 of them. And then the arc length formula, the angle of a sector, we are having 2 of them. And then now we have this formula here, where h is the height of the segment, the diameter, and the length. It depends on the question what you need to calculate there. Then this is the formula that you may use for those 3 conditions. And then we have a formula for mid-ordinate rule. And then this is for the irregular shape, area of the irregular shape. So that is your first one and the second formula. Take note, grade 12, that this m, all these m's that you see there, 1m there stands for ordinate 1 plus ordinate 2 over 2. So there's no value that we can just substitute there. You need to take your ordinate and calculate them. And then for the second one, for example, if I'm looking at m2 there, that means I am looking at ordinate 2 plus ordinate 3 over 2 continuously. So when you are substituting up to your last ordinate there. And then with the second formula now, this ordinate, the last ordinate, that is the ordinate before the last one. Because now we have already substituted the last ordinate there. So you can't repeat the same thing here. Be careful, grade 12. This must not be the same as that one, because this one is just before the last ordinate on your given ordinate that will be presented on your diagram. And then we have Pythagoras theorem. We know Pythagoras only works with a triangle of 90 degrees or a right-angled triangle. This cap here, when you see that square cap there, it is a cap that is indicating an angle of 90 degrees. So a side that is opposite the 90 degrees is your hypotenuse side. And then we have side A and the side B there. One will be adjacent and the other one will be your opposite side depending on which angle are you referring to, because we have an angle there and another angle there. So this one depends on the point of reference in terms of an angle. And then now original Pythagoras theorem, remember we are used to x squared is equal to the x squared plus y squared. So our r in this case is indicated by c, that is why you see as c squared. And then our x is indicated, it can be x opposite or whatever, but in this case we have substituted with a there and then substituted with the b because b is that sign. So that means now the Pythagoras is saying the square of the hypotenuse is equal to the sum of the squares of the other two sides. So now grade 12, you can play around with this one. It depends on which side are you looking for. If we are calculating the hypotenuse side, that means the hypotenuse C will be equal to the square root of what? Of your a squared plus the b squared. That means if this side loses an exponent 2, this will gain a square root there. Okay, that is what we mean about the first one. And then to find the side A there, that means now we are looking for this side, we'll be taking b to this side. That is why we are having c squared minus b squared there. And then if we lose exponent 2, we will have a square root on that side. The same applies if we are looking for b there. So we are looking for that b, will take a squared to this side. It will be c squared minus a squared. And then now if b loses an exponent, this side will gain a square root sign. So that is how we play around with Pythagoras there. And then we have trig ratios now. Remember we said the side that is opposite to the 90 degrees is your hypotenuse side. And then in reference to theta now, theta is that angle A there. And then this will be opposite to that angle. And then this will be adjacent. Can you see that it is sharing the same line with your angle? That is an adjacent side. And then now if we seated there at B, then opposite will change to be that one and then the adjacent. So it depends on the angle of reference grade 12. So now if we are having, remember your soccer tower, that is assisting you to remember your ratios. And then now when you have sine, this means sine is opposite over hypotenuse as we have indicated there. So in reference to theta now, here's sine theta, the opposite side is BC over the hypotenuse side AB. And then the cos theta is adjacent over hypotenuse, adjacent over hypotenuse. What is the adjacent side? That is AC. And then the hypotenuse side is still AB. And then now with the tangent is opposite over adjacent. What is the opposite side in reference to theta? That is side BC. And then the adjacent is AC. So grade 12, that is how you identify your ratios in terms of the 90 degrees triangles, or using the Pythagoras. We're using the trig ratios in a right angle triangle. So this will assist you. Soccer tower, or you can use your y over r. Remember this one is when you are using a Cartesian plane. So now when you are looking at sine, it will be y over r, and then the cos theta will be x over r, and the tan theta will be y over x in reference to your Cartesian plane, grade 12. And then now the reciprocals of this, remember now, the reciprocal of sine is a cosec, of cos it's a sec, and then of tangent it's a cot, or vice versa. When you are having a cosec, then this goes with the sine. Okay, you can easily maybe take it back. If you look at the third letter that starts with S, therefore this is leading you to sine. The third letter there is C, it is taking you to cos, and the third letter is T there, therefore is taking you to tangent. This will easily, grade 12, assist you to remember your reciprocal. So when you take it from reciprocal back to trig ratio, use the third letter on that reciprocal. So now sine is 1 over cosec, and cosec is also 1 over sine. and the cos is 1 over sec, and sec is also 1 over cos. And then with the tangent, tan is 1 over cot, and then now cot is also 1 over tangent. Remember now we talk to the sine theta that is opposite over hypotenuse, of which is y over r in your Cartesian. So when you talk cosec now, it will take the inverse of that one. The hypotenuse on top over the opposite, okay? Also r over y. So you are swapping everything when you are taking its reciprocal. Cos is adjacent over hypotenuse, sec will be hypotenuse over adjacent. If it is x over r, it will be r over x. And the tangent opposite over adjacent, it will be adjacent over opposite. If it is y over x, this one will be x over r. Remember now we have SOHCAHTOA for original ratios, and then for this one you can use a CHOL, SHAM, COW to remember the reciprocals of this, but it is easier if you use the originals to identify the reciprocals later. Then now for reduction formula, you use this, you need this diagram, of which is your cast diagram, your cast diagram, or any abbreviation that you can use, grade 12, that can remind you on how to do you identify your quadrants here. Remember, we are revolving anti-clockwise, and then start from 0, 90, 180 to 70 and 360 line back there. And then now in quadrant 1, all your ratios are positive. In quadrant 2, it's only sine that is positive. That means cos is negative and the tangent is negative in that quadrant. In quadrant 3, it's only tan is positive. That means the sine is negative and the cos is negative in that quadrant. In quadrant 4, cos is positive. That means when tan is in that quadrant, it will be negative, and also the sine will be negative, grade 12. So this is the diagram that we'll be using when we are reducing our angles to be less than 90 degrees. And then now, when we are revolving for the second time now, you have revolved, and up to there. And then now we are at 360 now. When you continue with the second revolution, this will be more than 360 now. It will be at 360 plus there. And then we have special angles. And then the special angles, now we have 30, 45, 60. And then now they can be written in radians as radian over 6. This one is radian over 4. This one is radian over 3. And then these are the values of x, y, r, depending on the angle that you are having there. You can also get this using your calculator, grade 12. Don't stress about the values there. And then we have our unit circle there. The unit circle, now we have the angles at 0 degrees, 90, 180 to 73, 60. And then this will have coordinate 1 and 0, 0 and 1, 0 and minus 1, and then a minus 1 and 0, and a 0 and minus 1. So these are the special angles, grade 12, that you will be using. Your calculator will give you the exact value now. And then you need to change degrees to radians, and then radians to degrees also. To be able to do that now, changing a degree to radian, you are changing what? A degree to what? To a radian. That means the degree must be on the denominator there. Here we are changing a radian to degree. That means a radian must be on the denominator. If I change a degree, degree must be in the denominator. If I change a radian, it must be 180 over a radian, because I am changing to radian. And then this is the circle that can assist you. We will be mostly referring to 2 radians. You must know is the same as 360 degrees angle. And the 180 degrees is the same as 1 radian. And the 90 basic, the basic ones is radian over 2. And the 270 is 3 over 2 radian. And then now others you will be able to calculate using this guide that I've just given you on the right-hand side table there. And then trigonometric identities, we have the square identity, reciprocal identities, and the quotient identities. I've already talked to this on the formula sheet. You have all these 3. of which sine squared plus cos squared equal to 1. Remember, you can play around with them. Tan squared plus 1 is sec squared. 1 plus cot squared theta is equal to cosec squared theta. I've already indicated that the reciprocal of a cosec, you look at the third letter, it will be 1 over sine. And the of a cot, you look at the third letter, it will be 1 over tan. For the sec, you look at the third letter there, it will be 1 over cos. I hope this key will assist you to remember that. And then we have quotient identities. A tangent is sine over cos. Remember, a tan is an inverse of cot and the cot vice versa. So if a tan is sine over cos, cot will take a cos over sine because they are always swapping around because of being reciprocals. And then you have sine rule. I've already talked to this on your formula sheet that to use a sine rule, you must be given two sides and angle that goes with that side, either this angle or that one. It must be the angle that goes with one given side, or you must be given two angles and the side that goes with one of those angles, then you'll be able to use sine rule. Cosine rule, you must be given two sides and included angles. For an example, if you are looking for A, you must be given B and C and an included angle A. Can you see that it's an angle between those two sides? That is why we are saying it must be an included angle. For the area rule, again, you must be given two sides and included angle. That means you must be given A and B and included angle. Included, it must be between those two equals given sides. Okay. So that means for cosine rule and area rule, you must be given two sides and included angle. And then grade 12 here is your baseline assessment. I am giving you 3 minutes to complete this trig ratios in reference to the angles that are given there. And then your 3-minute grade 12 starts now. Okay, grade 12. Remember our WhatsApp number 079 578 2908. Right. The important thing here is you need to look at the reference angle. We are referring to angle B. That means you will be standing there as you identify. Now remember the side that is opposite to the 90 degrees is your hypotenuse side. The side opposite angle B is this one. That means it will be your opposite there, and therefore this one will be adjacent. Now you look at your trig ratio. Now you're looking at the tangent. Remember your SOHCAHTOA? If you're looking at tangent, that means you need opposite over adjacent. What is opposite here? That is RH. Over adjacent, which is BH. That is the correct ratio for that. And then cos B, yes, we are still sitting at B there. And then the side angle opposite 90 degrees, that is your hypotenuse. And then the opposite side to B is this one. And then this will be adjacent. And then easy now, grade 12, we are looking at the cos. Cos is what? Adjacent over hypotenuse. Adjacent of which it's SB over hypotenuse of which is BT. So this is basically SB is equal to 20 and the BT is equal to 25. The same applies on number 1 there. Our RH is equals to 12 and then our BH is equals to 9. And then now with number 3 now, the tan of M, you look at reference, you must stand at M there. And then this is our hypotenuse side. And then now opposite to M is this side, adjacent to M is that side. And then we are looking at the tangent. Tangent is opposite over hypotenuse. Opposite is 8 over hypotenuse 17. And then sine G, you are standing at G there. This is the hypotenuse side. This is the opposite to G. That is the adjacent to G. And then we are looking at which ratio? The sine. Sine is opposite over hypotenuse. Opposite is 32 over hypotenuse 40. And then number 5, we are referring to angle G there. And then now this is the hypotenuse side. This is opposite to G and this is adjacent to G. And then we are looking at the ratio tangent again. That is opposite over adjacent. What is opposite? 15 over adjacent 20. And then number 6, we are referring to angle C now. And then this is the hypotenuse side. Opposite to C is this side, adjacent to C is that side. And then we are looking at the which ratio? The cos adjacent over hypotenuse. Adjacent is 28 over hypotenuse of which is 35, grade 12. That is how you were expected to answer that particular baseline. I hope all went well with you. And then we are having the terms that we are using that we will be referring throughout. Right angle triangle, I've already indicated it's a 90 degrees triangle, a triangle with one angle of 90 degrees. And the hypotenuse side is the longest side of the right angle triangle, and then it is always opposite the 90 degrees angle. Opposite side, the side opposite to the angle of reference in a triangle. And adjacent side is the side next to the angle of reference in a triangle. And then quadrants is the 4 areas formed when we divide a plane by X and Y. Okay, like in your Cartesian plane, those are the quadrants 1, 2, 3, 4. And then reduction is to rewrite any trig ratio with an angle reduced to acute angle. Acute angle is an angle that is less than 90 degrees. An angle of elevation is measured from a horizontal plane upwards. An angle of depression measured from horizontal plane downwards. And then now the range is all possible values of y that lies on the graph a domain, all possible values of x that lies on the graph. And the period is the distance taken by a trig graph to complete one full cycle. And then amplitude is the height of trig function from the center of the graph to the maximum of the graph. And asymptote is the line which the graph never touches or cross. That is an asymptote line. You found this in all our graphs grade 12. It is there on the hyperbola, also paper 1, and then on the exponential function also. So it's a line that the graph will never ever touch. And then now let's look at this activity here. We are given angle P, which is radian over 4, and angle Q, which is 90 degrees. And then on 1.1, you need to convert this angle P to degrees now. Remember now we are converting angle P, of which is radian over 4. We are converting to what? To degrees. Do you still remember now if I'm converting to degrees from radians? That means the radian must be on the denominator so that it can cancel that one. Therefore, it will be 180 degrees over radian. So that the radian can cancel a radian, then we are left with 180 degrees over 4. And this will give us an angle of 45 degrees. If you landed at that 45 grade 12, then you'll get your 1 mark there. And then to determine the second one, we are determining the value of cot squared P by sine squared. That means grade 12 here, we are using the substitution method to answer this question because we have the value of P and the value of angle Q there. So now cot, again, you need to check the cot is 1 over what? The tan, the reciprocal of that one. So we are going to write this cot as 1 over tan squared, and the P value we can automatically substitute, that is 45 degrees as we have calculated on 1.1, and then plus the sine of Q. What is Q? Q is 90 degrees. Then you'll have your 1 mark there for substitution and another mark for writing cot in reciprocal. And then now the next step, we need to substitute now 1 over tan squared 45 tan 45 is equals to 1. And then 1 squared is also 1. 1 over 1 is 1 plus the sine of 90 is also 1. Then this will give us 1 plus 1, of which is 2. So the first mark will be for writing that in its reciprocal form. Second mark for substituting the angle 45 and 90. The third mark will be for your answer there. That is how you get your 3 marks for this particular activity there. And then grade 12, let's see now, can you do your own activity on the substitution part only? And then now I am giving you 3 minutes to do this activity, grade 12, where you are given A is 103 degrees and B is 52 degrees. Use a calculator to determine. You are allowed to use a calculator after substituting to find those values. Your 3 minutes, grade 12 starts now. Okay, grade 12s, we are given A is 103 degrees and B is 52 degrees. So in 1.1, they say use a calculator to determine the value of tan A plus B then. So ours is just to substitute. This will be tan, what is A? 103 degrees plus 52 degrees. So we want to see that substitution, grade 12. And then from there, you can just put in your calculator straight to the answer. This will be negative 0.47. And then it's 1 mark for substitution and 1 mark for your answer. That is your 2 marks. And then with this one now, look at that, you are having a reciprocal there. And then the third letter is saying S there, that means it will be 1 over sine. So now it will be 2, because we have 2 on top there, over sine theta. And then we can automatically substitute grade 12. We are having 2 over the sine. And then what is B there? 52 degrees. And then now divide by the cos of A. We are dividing by cos of A. How much is A? 103 degrees. So that will be your first step. And then now from here, now you can just put everything into your calculator straight to the answer. This is negative 11,28. So your first mark, grade 12, is for changing a cosec into 1 over sine 52. And then the second mark is for substituting the 52 degrees and 103 degrees at the correct place. Where there is B, you put the B value 52. Where there is A, you put 103. And then the final answer is negative 11,288, rounded off to the correct decimal place and correctly rounded off, grade 12. And then now the next question, you are given the sketch to determine, without using a calculator now, without the use of calculator, the values of the following. And then now the first question, they say determine the length of QT. Okay? Determine the length of QT. If you go into that diagram, QT is this side here. So now we are given angle 58 degrees. We are given that x is 1. We are given the hypotenuse there, of which, so we have the r value, which is equal to that. We have the x value, which is equal to, therefore we are looking for the y then. So in order to find the y, of which is QT, we are going to use the Pythagoras. Remember now, Pythagoras says that the QO, of which is the hypotenuse side, squared is equal to the sum of the other two sides, that is OT squared plus the QT squared. And then what is QO? Square root of 5 squared equal to OT, 1 squared plus the QT squared. So now square root of 5 squared is 5. 1 squared is 1. When you transpose to the side, it will be minus 1. And then we have our QT squared then. And then now we are looking at the y value that is positive, right? Because according to the quadrant then, that side must be a positive y value. And then now this side loses an exponent, QT will be left there, and then we are is equal to the square root of 5 minus 1, of which is 4. We are taking the positive square root because our y is positive. Therefore, QT will be equal to positive 2. So now we have a value of this, which is equals to a 2 there. So now this is 2 marks. It's 1 for substitution and 1 for getting the correct value of QT there. And then can you see grade 12? I've added the value on the diagram so that it can assist me to move further with this application. And then one other thing, grade 12, you can put the value of the other angle that is missing there, because in a triangle, if you are having 2 angles, sum of angles of a triangle is 180 degrees. Then now you can easily find this angle here if we say 180 minus 90 minus 58, then we're left with 32 degrees. Okay, and then let's look at question 2.2 now. It is saying 2 bracket of cos 58 degrees. And then now what is cos 58? Remember, a cos, do you still remember your soccer tower? We will be using this most of the time, grade 12s. And then now when you look at cos, cos is adjacent over hypotenuse, but you are sitting at angle 58. So to 58, this will always be hypotenuse, it's fine. And then this one is the adjacent, and then this will be your opposite side if we talk to 58, right? And then now we are looking at the adjacent over hypotenuse. That means now in this case, it will be adjacent is what? 2 over hypotenuse, which is square root 5. Remember, this ratio is squared. Then now it will be 2 squared equal to 4. The square root of 5 squared will just be a 5. That means it's 1 mark for substituting and 1 mark for the answer there. And then moving forward to the next question there, this angle here, it is in radians. That means you need to start by changing that to degrees. Then this will be equal to the sine 32 degrees plus the sine of that value there. Then when you are changing 29 over 90 radians into degrees, you multiply by what? 180 degrees over radian, so that this radian can cancel that one. And then if you look at that value, grade 12, it is giving us how much now? The radian value is 58 degrees, right? Here you have indicated already the 32 because there's a 32 on your diagram. Can you see now how helpful is indicating that remaining angle there? And then now for the second one, we are looking at the sine of 58 degrees. And then now we can now start looking at the values now. Sine is opposite over hypotenuse, but when you are sitting at 32, this will be your opposite. What is opposite? 2. And then hypotenuse, square root 5. Plus the sine of 58. If I'm sitting at 58, which one is opposite now? 1. Over hypotenuse is the same, of which is square root 5. Then my answer will be 2 plus 1, of which is 3, over the square root of 5. And then now if grade 12, you are rationalizing this, you will multiply by square root 5 over square root 5 there. And this will be 3 square root 5 over 5. So now this is 2 marks. It's supposed to be 1 mark for changing the radian into degrees. The second mark for substitution the correct ratios. And the third mark for your answer. This problem was worth 3 marks, grade 12, not a 2. Okay. And then moving on to the next question here. We are given 3 cosec theta plus 5 is equal to 0. It is still using a sketches, but now here the sketch is not given to you, grade 12. Okay. And then they say this theta angle lies between 90 degrees and 270. Remember, when you have your Cartesian plane, this is your 90 degree, your 90 degrees, your 180 there, your 270, and your 360 there. So if they say it lies between 90 and 270, that means it's quadrant 2 and 3 there. That is what this statement is saying to you, right? Now, 2.1, they say make cosec the subject of the equation now. We are looking at that equation. We want to make cosec subject of the formula. We are going to transpose 5 to the side. We will be left with 3 cosec theta equals to minus 5. And then we divide by 3 both sides. Then a cosec theta is equal to minus 5 over 3. bear in mind that a cosec is a reciprocal or an inverse of sine. That means if cosec is minus 5/3, the sine theta will be what? Minus 3/5, because we are swapping around. Okay? But for this question, we're expected to end up there and give us the solution as minus 5/3. Right. And then now, remember now a sine is y/r. That means the cosec is r/y. So 2.2, hence determine without using a calculator the value or the values of cos theta minus a cot of theta. Remember now, you cannot just answer this question until you have all your values, because cos is x/r, whereas here we have only y and r. So in order to find that, you need your diagram, grade 12. We must start by indicating in which quadrant is this ratio now according to that restriction. So now this cosec is negative. Remember, cosec goes with sine. So if it is negative, it must be in quadrant 3 and 4, because in quadrant 1, all ratios are positive. In quadrant 2, cosec and sine are positive in there. But here we are looking at the cosec that is negative. That means it must be in either 3 or 4. But restriction is saying to us, work in 90 degrees and 270, between 90 and 270. Where do we have a line and a tick? It is in this quadrant. Therefore, this will be our final quadrant to sketch our diagram. Okay, and then this is the triangle of 90 degrees. And then now the cosec, our r, is equal to 5. And the value of y will be minus 3. So we are looking at the value of x, of which is also negative according to that diagram. After identifying that, grade 12, we can now go Pythagoras and look for the other x value, the value of x there, because we don't have. So we are going r squared is equal to x squared plus y squared. Okay? No diagram, no Pythagoras for this type of questions. You must start by diagram first, because you need to know whether your x is positive or negative. It's only your diagram that can give you that. And then what is the r value here? It's 5 squared. And the x value, we are looking for that. And the y value is minus 3 squared. And the 5 squared is 25, equal to the x squared. And then the minus 3 squared is 9. And then 25 minus 9, we are having 16. That is x squared. So to get the x value here, we are looking at the square root of 16 plus minus that. But because our x is negative, we'll take only the negative one. Therefore, x is equal to negative 4. So now if we can collect our data here, we have x equal to negative 4. The y equals to negative 3, and the r equals to 5. R is always positive. And this works only if your angle is theta. And then now it's only then that we can answer that question, grade 12. And no one will guide you through. You must know that before you answer that question, you need to go all that route of diagram and the Pythagoras theorem. And then now let's answer the question. We are having the cos of theta minus the cot of theta. The cos of theta now is adjacent over hypotenuse. And then the adjacent is what? Is the x over r. Minus the cot is the inverse of tangent. Remember, tangent is toward, opposite over adjacent, or the y over x. Then the cot will take x over y. And then let's substitute now. What is the x value? Minus 4, the r value 5, minus the x value minus 4, the y value minus 3. And then this is minus 4 over 5, minus the negative will cancel negative, we are left with 4 over 3. And then we can put this into our calculator straight to the answer is minus 32 over 15, grade 12. Do not change this into decimals. You must leave it in fraction form because they said without using a calculator there. So the first mark will be for substitution. The second mark for the answer there. The third mark for the diagram for substitution into Pythagoras and for the correct x value. Therefore, this problem with 5 marks, grade 12. And then now let's look at the equations. Now, these are the trig equations. We are given that solve for t if cos 60 plus 2 sin t equals to 0, for t being between 90 degrees and 270. That means your angle after calculating must be between 90 degrees and 260. Nothing less than 90 or greater than 270. So now we have this equation now. We are going to have 2 sin t equal to minus cos 60. 2 sin t is equal to minus, what is cos 60? Cos 60 is a half. And then now we divide both sides by 2 or multiply by 1 over 2 to cancel that 2, multiply by 1 over 2. So the sign of t will be equal to negative 1 over 4. And then we look at the reference angle of t. And then this will be the arc sine of 1 over 4, Rachel. Look at this, I'm not including the negative. Why? Because this negative indicates the quadrant of which where sign is negative. Which quadrants are those? That is the third and the fourth quadrant. So we'll be busy in those quadrants, okay? And then now we are looking at the reference angle for sine arc, that is 14,48 degrees. So now we want to look at the solution in third quadrant here. In the third quadrant, we are having t, angle t is equal to reduction in third quadrant is 180 degrees, plus we will be adding this 14,48 degrees. And then this is giving us 194,48 degrees. Check the number. Does it lie between 90 and 270? Yes. And then now we will stop here, grade 12, because now when we go to quadrant 4, let's see what will happen now. When we go to this quadrant now, fourth quadrant, we'll be having angle T is equals to reduction in fourth quadrant is 360 degrees minus the reference 14,48 degrees. And then 360 minus 14,48, grade 12. Can you see that it will be more than what we are expecting then? Okay, if you remove that, that is 360 minus the 14,48 there. Okay, we'll be having 300 and something as our angle there. It is more than 270. That is why we are not calculating into that quadrant, because the angle will be more than 300. Okay, we must only have our solution between 90 and 270. Then the first mark will go for the simplification of having 2t equals to half. The second one for having sin t equal to 1 over 4. Third one for the reference angle. And the fourth one for the final angle there, which is 194,48. So this is worth 4 marks, grade 12. And then now, activity number 3. Please try this one on your own now and check whether can you solve that equation. I am giving you 3 minutes to solve this equation. And then now we are solving for cos 3x equal to minus 0,43. And then your 3x must lie between 0 and 360. Be careful, your 3x, not your x, ne? And then this is worth 5 marks, grade 12. I am giving you 3 minutes to try this one. Your 3 minutes start now. Okay, grade 12, let's see how far did it go with this one. Remember our WhatsApp number 079 578 2908. You may send any clarity seeking question to that particular number. Right, we are solving for x on this one. You are not allowed to divide by 3, grade 12. This is an angle is binded together like that. At this stage, you can't divide by 3. So now we will go straight to our reference angle of 3x now. And then this will be the arc cos. Okay, remember you go second function and then cos. Okay, not 1 over cos. It's not the same thing. The arc cos is not 1 over cos. It's your shift on your calculator or second function cos. Okay, so when we say arc cos, we mean shift cos. Okay, and then now with the 0.43, can you see I am omitting the negative because this negative is indicating where cos is negative. That is the second quadrant and the third quadrant. So those are the quadrants that you will be working in. And then now into your calculator, arc a second function cos 0.43. It is giving us how much? 1264.53. Remember, this is the reference of 3x. Is it correct now? Does it lie within the interval? Yes, because 64 is within the interval. And then now we can now take this into the quadrants now. Remember, this is reference, it's not yet your solution. So you are going to solve in second quadrant and the third quadrant. So in the second quadrant now we are having 3x is equal to, what is the reduction in second quadrant? 180 degrees minus what? Your reference 64,53. And then now 3x is equals to 180 minus 64,53. That is 115,47 degrees. And then divide by 3 both sides. Therefore, x is equals to 38,49. Check this level, grade 12s. Can you see that your 3x is within the interval? Okay, that is why we continue solving. And then now on the third quadrant, now your reference 3x is equals to, third quadrant is 180 plus, and then plus what? Your reference 64,53, and then 3x will now give us 180 plus 64,53. And then that will be 253, that is 4, 8, 10, 4. That is 244,53. And then we are looking for the value of x, sorry, grade 12 for that. We are looking for the value of angle, but look at 3x. Does it qualify within the interval? Yes, it lies between 0 and 360. Now we are dividing 244 with a 3 now. That will be 18. 1,16 there. And then this is the x value of that particular angle. So now the first mark will go for the reference angle, second mark for the reduction in the correct quadrant, and the answer reduction and the correct answer there. And then this is worth 5 marks, grade 12. You are not allowed to divide this by 3 at that level because this is your reference angle. You can only do that when you have now arrived on your quadrants where you are solving. Okay. And then our next lesson, simplify without using the calculator, the sec 180 plus b. Here we are using the reduction method now. So we need our reduction quadrants, cast diagram. And then in quadrant, remember reduction in TechMath, we are only using 180 degrees and then 360. We don't reduce 90 and 270. We are not using that line. So now remember 180 can also be a radian, okay? Or 360 can be 2 radians there. And then in quadrant 2, we are having, remember this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So in quadrant 2, we are having 180 minus. In quadrant 3 is 180 plus, or a radian minus or radian plus. And then in quadrant 4, we are having 360 minus. In quadrant 1 is 360 plus. So it's either 2 radian minus or 2 radian plus when we are in quadrant 1. So we will be referring to this table now. As you are starting with your reduction, you must start by writing this table, grade 12. It will assist a lot. Then now, for the first one, they say, simplify sec 180 plus beta. Remember now, a sec goes with a cos. That means we are in this quadrant now. We are in quadrant 180 plus b, okay? 180 plus b is this quadrant. In this quadrant, it's only tangent that is positive and it's reciprocal of which is cot. So now if sec goes into that quadrant, it will be negative sec b. Remember, we use 180 plus to identify the quadrant 180 plus. And then now this is giving us quadrant 3. Then we check sec in quadrant 3. Is it positive or negative? No, sec is negative. That is why we write this negative here. We bring a sec and then we are left with only b because we have now applied the quadrant 180 plus. Then this is your 1 mark. And then 4.2, we are given tan squared 2 radian minus beta. 2 radian minus is which quadrant? That is quadrant 4. Let's check now. Is tangent positive or negative? No, tangent is negative in that particular quadrant. And then that means now, this square, remember, it means 2 bracket of that, okay? If tan is negative, it will be negative tan of the beta because we have now applied 2 radian minus to identify the quadrant. So it will be minus tan b minus tan b because we are having 2 of them, okay? And the negative times the negative, it will be positive. A tan by tan is tan squared b. So that is 1 mark for showing tan squared b. But you must understand, grade 12, it comes from 2 negatives. That is why it's a positive tan. And then now 4.3 now, the hence question, because we will be applying what we have in 1.1, what we have in 4.2 there. And then now we are having a cos of 120. Remember, 120 is the same as the reduction 180 minus. That is quadrant 2. How much must I subtract now to get 120? 60 degrees. Okay. And then now let's go cos. That is 180 minus quadrant 2. In quadrant 2, cos is negative. Then you'll be having negative cos of 60 degrees. Multiply sec 180 plus, we have already calculated. It will be a minus sec b from question 1. And then all over the tan squared 2 radian minus b, we ended up with tan squared b. That will be tan squared b. And then divide by cos 360 plus b, that is quadrant 1. All ratios are positive, then it will be cos b over 2. Continue. The cos of 60 is how much, grade 12? That is 1 over 2, then it will be minus 1 over 2 for cos b. Multiply by the sec of b, it is 1 over cos minus 1 over cos b all over the tan squared b, a tan sine over cos, that will be sine squared b over cos squared b. Then we change this to multiplication, it will be 2 over the cos b. Right, the cos of b there will take 1 there, then you'll be left with a negative half times that, it will be positive 1 over 2 cos b. Okay, multiply by that 2 on top there. And then on the denominator now, this is the numerator, right? On the denominator, we are left with divide by sine squared b over cos b. Remember now 1 cos b have cancelled 1 there. We are left with 1 cos b. And then this is equal to 2 over 1. 2 goes once there. We are left with 1 over cos b. We change division to multiplication. It will be a cos b over the sine squared b. Cos will cancel a cos. We are left with 1 over sine squared b. What is 1 over sine? Grade 12, that is a cosec square b there. And then let's look at the mark allocation one. It will be 1 for reducing this angle to cos 60 minus cos 60. And then minus 1 over cos b. And then now for changing this to its reciprocal, 2 over cos b, And then for substituting the value of cos 60 there, that is your fourth mark. And then now the other mark for the identity of a tangent sine over cos. And then for 1 over sine square b, and for your final answer. Therefore, for this one, we can add 2 marks, and this problem can worth 8 marks, grade 12. Okay. We are still on the reduction. And then complete the following. We are looking at cos squared 180 plus alpha. Remember, we are still using that reduction. When we are here, it's your 180 degrees, which can also be your radian, or it can be a 360 degrees with a 2 radian there. So from here is 180 minus 180 plus 360 plus 360 minus. Okay. And then we have 180 plus. 180 plus is quadrant 3. Remember cast diagram. You check your ratios there. We are having a cos squared 180 plus. 180 is quadrant 3. Cos is negative on that quadrant. Then it will be no negative cos alpha. But because it is squared, it will be 2 of them. So a negative times negative, it will be cos, positive cos squared alpha. That is your 1 mark. And then the sine squared plus cos squared is an identity which is equals to 1 grade 12. That is your 1 mark for that. And then for number 6 now, for now 4.3, which is 6 marks, we are having the tan of radian minus alpha. Radian minus alpha, that is quadrant 2. What is tan there? It's negative. Then it will be equal to negative tan alpha. And then multiply by the square root. 1 minus sine squared is this identity now. If you take 1 sine squared to this side, it will be 1 minus sine squared. Therefore, you can write it as cos squared alpha all over cos squared into 180 plus alpha. We have already answered that. That is cos squared alpha. And then we have a plus 360 minus is quadrant 4. And in quadrant 4, sign is negative. But because it is squared, it will still be positive. Then we will end up with positive sine squared alpha, because it's 2 negatives now, which gives you a positive. And then from here now, a tangent is sine over cos. Again, you are bringing in your sine squared, or it's not squared, sine alpha over the cos alpha, and then multiply by a cos squared. The 2 will cancel the square root sign. You'll be left with cos alpha. And the cos alpha, we cancel cos alpha then. All over sine squared plus cos squared is equals to 1. It's the same thing. It's just that they placed a sine this side and a cos. So 2 plus 1 is the same as 1 plus 2. The answer is 3, okay? So the same applies here. Sine squared alpha plus cos squared is the same as cos squared alpha plus sine squared alpha, which is 1. And then we are left on top with minus sine alpha over 1 is the same thing. And this is what 6 marks grade 12. The first mark will be for reducing tangent. The second mark, reducing what is inside the square root sign. The third mark for reducing the 360 minus alpha. And then the fourth mark will go from identity cos squared plus sine squared is 1. And then the fifth mark for writing tangent sine over cos. And the last mark for the answer there. Then this problem is worth 6 marks, grade 12. And then now, question number 5. We are given complete the identity. Remember now this one comes from, can you see that, grade 12? Is the sine squared 1 plus the cos squared equals to 1. So if you take cos to this side, it will be 1 minus cos. Therefore, this identity is equals to sine squared A. Therefore, it's your 1 mark then. And then now let's look at 5.2 now. Hence, prove the identity. You are proving that our left-hand side will be equal to the right-hand side. So that means this is the answer that is given to you, right-hand side, if you simplify the left-hand side. So now we are adding two fractions. That means we apply the LCM or LCD method. Our LCM is 1 plus cos A into 1 minus cos A. And then we use our application now. 1 plus cos A will cancel 1 plus cos A. We are left with 1 minus cos A times 1, which is 1 minus cos A. And then we have a plus in between. And then now 1 minus cos A, 1 minus 1 plus cos A times 1 is 1 plus cos A. We are taking the left-hand side great terms. So now cos A minus cos A is a 0. So 1 plus 1 will give us a 2 over. In the denominator, you can see you have the difference of 2 squares there, factorization. So we can take this back to 1 minus cos squared A. Because it will be 1 times 1 is 1. 1 times minus cos is minus cos. Cos times 1 is cos A, then 1 cos A minus cos A will cancel. And the cos A times cos A is cos squared A great 12. Remember that one. And then now 2 over. You still remember 1 minus cos squared is the sine squared A. We did that on 5.1. And therefore now, remember, this is actually 2 times 1 over sine squared A. What is 1 over sine? It's a cosec. Therefore, this will be 2 cosec squared A. Then our left-hand side is exactly equals to our right-hand side. So 1 mark will be for, let's look at the mark allocation now. It will be for the LCM or LCD for simplification on top there. And the 3rd mark will go for 2 on top. The 4th mark for the denominator. And then for end up with that identity, or we won't give a mark because we have already given a mark on number 1 there. And then this is our 4 marks grade 12. It is 1, 2, 3, 4 marks, because this one is already allocated there. We can't allocate a mark again. And therefore, this will take us to that 2 cosec squared, which is on the our right-hand side. And then now we have another identity application here, where we have the left-hand side and the right-hand side here. And then let's see now great terms. Let's say we are taking our left-hand side to solve this problem now. Remember, in some cases, you can even your right-hand side, use your right-hand side, it works well, okay? In this case now, let's say we focus on the left-hand side now. And then now we are having a sec. Remember, sec is a reciprocal of a cos. We are going to write this as 1 over cos squared theta. And then plus the cosec is 1 over maximum value. Happy it is 2. That means the value of A is equal to 2. Basically, it means now the equation of K at X is equal to 2 cos X. 1 mark for the value of A there. And then what is the domain of H? The domain is the X values that lie on H graph. H graph is a sine graph, okay? H graph is a sine graph. So this sine graph starts from 0 and end up at 270. That is the domain for this graph. So our domain now will be X is an element of starting from 0 degrees and ending at 270 degrees. That is the domain, X values that lie on the graph. And then it's 1 mark for the correct bracket and then 1 mark for the correct values there. Bracket must be square bracket because 0 and 270 are part of that graph. They are part of our graph grade 12. It's included, the values are included. And then what is the period for K now? For the K graph, that is the cost graph. If you look at this cost graph, it's not complete. It was supposed to continue there and move to 360 to have a complete graph. How do we know that? There is no value there. This is 1x. So that means we'll be having a complete graph at 360. One complete graph at 360 because the coefficient of x is 1. Therefore, the period for this will be 360. A complete cost graph will be at 360 degrees. That is worth 1 month. And then the diagram below shows the graphs of the function h at x equal to 2 sine. We are still on the same graphs. Remember, this is minus sine 2x. Remember, this one is a 2 cos x graph. Now, this is the h graph. Let me highlight that again. This is the k graph. And then this one is the cos graph. And this one is the sine graph. Now they say write down the intervals for which the h at x is less and equal to k at x. If it is less, it will be below. This one will be above. Okay, we are going to look at the condition where the h is below, k is above, right? So k is above, yes, is this interval here. And then here h is above. We can't take this interval, right? We are looking where k is above, and k starts being above again from that interval. Those are the two solutions now. So our first solution will lie between the x0 and x90 degrees, between those two. And then remember, the values are inclusive, okay? So now for number D, our solution, the first one will be x between 0 degrees and 90 degrees. Or between what? The interval here, it is 270, 210, is 200 and what? 10 degrees here. 210 degrees, our x lies between that and 270 degrees. Hence, we have that 4 marks, grade 12. In order to get this mark, the notation must be correct. It's 1 mark for the notation, 1 mark for the values, 1 mark for the notation, 1 mark for the values there. Okay. And then for number D now, number E, sorry, the graph of F is obtained when the graph of H is shifted 30 units to the left, 30 to the left. We will take the graph of H. What is graph of H? H at x equal to minus sine 2x. What are you doing to that one? You are shifting this 30 to the left. So h at x is shifting 30 to the left. When you shift to the left, it will be plus 30 degrees. That means now this will be minus sine 2. You are shifting only on x. It will be x plus 30 degrees. After going this now, and then it must move 1 unit down. So now if it also move 1 unit down now, this graph will be the graph of f at x, of which will be now minus sine what? 2x plus 2 times 30, 60 degrees. And then it must shift 1 unit down, then it will be minus 1. So that is the equation of f in its simplest form. Okay, and this is 2 marks. It will be for this shifting and for that particular shifting. This is what 2 marks, grade 12. And then now moving forward. In this case, this is our last activity, I think. The graph represents the function of f at x minus 2 cos x. This is the f function we are talking to. And then the g at x function, of which is that one. it's a coarse graph again. Both of them are coarse graphs. And then for X, it's an element of 0 to 180. They are drawn only from 0 to 180 degrees. And then point M, 0 degrees, and B, and point J, it's C and 0. And then we are the Y-intercept and the X-intercept of G, respectively. And then L, D, and E is the turning point of graph G. And then K, 0 degrees, and A is the Y-intercept of F. And then write down the values of A, B, C, D, E. So now, grade 12, it is better to analyze the graphs now. We are given the F at X graph is -2. We are talking to this graph here. Let me highlight that in red. That is the F graph, okay? Let me also highlight the formula that talks to them. And then this graph is having an amplitude of 2. And then it starts at -2. That means the value of here is -2. Okay? And then now this goes like that and into up to 180. And then when you look at the coarse graph now, coarse graph is having amplitude 1 there. That means this is amplitude 1. And then now it is 2x there. That means now the period of this is divided by 2. That is why we have a complete graph at 180 there. Okay. And then now, if that is the case, now remember original graph, it is cutting at 90. You count by 90, 180, 270, 180, 360 degrees. It will be 90, 180, 270, 360. Now, because now it is reduced now to 180, that means we are going to divide each interval by 2, because now we have divided 360 by 2. That is why we're ending up at 180 then. So instead of having 90 here, we will be having 45. Divide by 2, 90 divide by 2. And then instead of having the 180 here, we'll have 180 divided by 2, of which will be 90 degrees. And then coordinating with the amplitude, remember it is 1, it will also be -1 down there. And then now, yeah, I think that is all that we need for now. Okay. And then now we have the values and we have identified that according to the knowledge that we have from the graphs. So what is A? A is equal to -2. Okay. And then what is B? B is equal to what? 1. And the C is equal to 45 degrees. And the D is equal to 90 degrees. And the E equal to a -1. It is easier for us because we have analyzed the first our graphs versus the formula that we are having for those particular, or the equations of those particular graphs. And then this is worth 5 marks, 1 each there, hence we have the total 5. What is the amplitude of F? F is the red graph now. Remember, an amplitude is a distance, is a wavelength from the X line to the maximum or the minimum of your graph. And then if we move from here to here, you can see that is -2. But in this case, now we are not considering the sign negative, because now here also we have a distance of 2 units. So our amplitude is always positive. Then the amplitude will be 6.2. Amplitude is equal to 2. And the 6.3, we are looking at the period of G. G, look at G now. Period is where you have a complete graph, okay? So look at G now. At 180, we already have a complete course graph. Therefore, now our period for this one will be what? 180 degrees. And then now, 6.4, the values of X for which F multiplied by G is greater than 0. Number one, we need to understand greater than 0 means it is positive. Product of the two graphs be positive. You can only get it positive if what? if both are positive. Positive times a positive is a positive. Or if both graphs are negative. That is the analysis of understanding that statement. Your graph must both be positive or both negative in order to satisfy this condition. Now let's go to our graph. On the graph, above the x-axis, the graph is positive. All our graphs are positive above here. Above, the graphs are positive. Below, the graphs are negative. Below, the graphs are negative. Below, the graphs are negative. So we are looking at the interval where both our graphs are negative or both negative. Then we have an interval that is starting there. Can you see that? Up to here. These graphs are both negative. Can you see that option, great jobs? This part here, both graphs are negative. We can't take this one because there is plus minus, but starting from here now, this graph is positive there, above. So also within this interval, the two graphs are positive. So our solution now lies in this interval here, negative, negative, and positive, positive interval there. So now let's write this in terms of x. That is between these x values now, okay? That means the first x value is between them 45 degrees and 90 degrees. Or another interval will be at 135 degrees and the 180 degrees. We can't include because the values are not equals to 0, they are just greater than 0. So that means it will 2 marks for that and 2 marks for this, for correct interval and correct values to get the total 2 marks, great jobs. Okay, that is your homework. And then this one is on 2D and 3-dimensional problem. You will be applying your sine rule, cosine rule, and the area rule to answer this activity, great job. All the best on that one. And then now on the summary of everything that you have done under trigonometry, now you must know your trigrations, you must know your reciprocals, you must know special angles and unit circle, you must know how to change degrees to radians, radians to degrees, you must know how to apply your reduction formula 180 plus minus and 360 plus minus. For reduction, we are only using those two. You must know how to apply your identities. You must know how to solve your trig equations, and then you must know how to solve 2D and 3D. Also know how to sketch trig functions and also how to analyze your trigonometry graphs, great job. This is the summary of what is expected of you on the trigonometry chapter. This lesson was brought to you by the Gauteng Department of Education in collaboration with Cybono Discovery Center. Thank you very much, great job. Wishing you success in your exams as you are busy writing. Remember, on Monday, you are writing your paper too. We are saying, may good luck be in your favor and your preparation bring fantastic outcomes. All the best, great job. Thank you.